Hey, hi everyone, welcome to this another interesting topic of system design. So this is the fundamental topic on whose basis we design multiple system design fundamentals. So the topic, as you can see on the screen, is written scale from 0 to million. So what is this 0 to million? So actually this is the number of users which we will be handling, or rather our web server or the web services will be handling to fulfill the request made by the user. So let's, without wasting any time, dive deep into discussing how we can scale our systems, the web servers, the database, the cache, and all other fundamental designs which we require to support millions of users in this video. So to understand how a web server actually handles a request, let's say currently we will be looking into the web service of Facebook. So currently what we have, our setup is, we have, let's say, 10 users who are using facebook.com. So now they can access this Facebook using a web browser, or rather a mobile application, which is nowadays being most preferred. So how do we access this? Let's say, how do these 10 users access this facebook.com? So for that, let's say some are accessing through web browser, some are accessing through mobile application. So in the web world, as you know, these names, actually the computers or the web servers don't understand these names. What they understand is the IP address. So there is a mapping of, let's say, facebook.com apps to an IP address or internet protocol access address to, let's say, 10.10.10.10. So how does the other internet gets this number or gets the access, how does the other web service knows that we have to return or handle the request of this IP address? So for that, what we have is a third party service, that is called DNS, or domain name systems. So what is the functionality of this domain name systems? So domain name system is a paid service which is provided by third parties, and these return actually the internet protocol addresses. So whenever we type www.facebook.com or we open the application of facebook.com, what happens? The request goes to the DNS. DNS in turn returns the IP addresses. So here, let's say it's 10.10.10.10, and once our application has this IP address, this IP address is used to obtain, or rather send, the HTTP request to the web server which is hosting this facebook.com service actually. So the web HTTP request is being sent to the service, and the service in turn returns HTML pages or JSON response for rendering. So let's say if the user is first time and he has opened this Facebook application, then he will be redirected to the login or the sign up page, or if he has already logged in, then he will be redirected to his newsfeed page, and etc., depending on the request which is the user is performing. So what are the traffic source from which this request comes to the web server? So as we saw, one is the web application and another is the mobile application. So web application uses server-side languages like Java or Python to handle the business logic, etc., storage, and client-side languages for like HTML, JavaScript, CSS to represent the Facebook page. Whereas the mobile application, what do they do? What protocol do they use in communication? That is the HTTP protocol, and JSON object is being returned is commonly the API response format to transfer data for simplicity. So this is an overall overview of how a single server setup works, and it is used to cater 10 users request, and for this we are using facebook.com as an example to understand. So now let's say with time, popularity of Facebook increases, the number of users is increasing with time, say, and currently the number of users, let's say number of users increasing day by day. So initially there was 10 users, so to store the user ID, password and other details of the user, this web server was able to handle, it has that memory to handle or to store the information about those particular users. But with time, this memory is being exhausted, right? Number of users is increasing and there's a threshold on the memory limit. So how do we cater those requirements? How do we store the user's information? How do we retrieve those information or authenticate or use that information to authenticate that user? For that, what we do is we introduce a database layer. So how does this database layer help us? Firstly, it helps us to cater the need of more memory requirement or storage requirement to store the user's information and other related stuffs or data. And secondly, what helps in separating us the database layer from the web server is like these have become independent now, and they are independent now, and we can scale them independently, right? So if we modify our design, so web server now communicates with a database layer to cater the needs of the users. So this is called a web tier, and this is called the data tier. So now, since we have introduced, so what does this database helps in operation? This database supports operations like read and write or update, and also return data upon request. Okay, so these are the basic fundamentals of our database as we know. So now let's say we have multiple databases available in the market, like relational databases, non-relational databases. So which one to use and when? Let's now look into the details of those. So database, it is of two types, like relational databases and non-relational. In relational database, we have the SQL database, which is most popular, and they help to perform join operations. Mostly data is stored in the form of tabular format, and these multiple tables have relation among them, and in order to retrieve data, we need to perform join operations among the tables to get the data and fetch the data actually. So popular relational databases is like MySQL or Oracle, etc. Whereas non-relational databases is like also called NoSQL databases. They are mostly divided into four categories in which we can store these non-relational databases. One is the key value store. So I have made a detailed video on how key value store actually occurs or actually happens. So I'll post the link in the description. You can have a look on the playlist. Second, we have is like in graph format. We can store the data. We have column store, and we have document. In form of document, we can store those data. These are non-relational. Actually, these data are in form of key value format, and they don't have any relation among them, so we can store them. So which one to use when? So depending on the use cases of these relational and non-relational databases. So in relational, if we are storing table in multiple formats such that each table has a relation between them, and in order to gather information, we need to perform join operations on the tables, then we prefer relational. Else, if there is no relation between the two data which is being stored, so and also non-relational databases has certain advantages. It is like if you want the retrieval to be very fast, like we want super low latency in data retrieval, or if we have the data is unstructured, it's not in the form of a table and it's like some JSON format, or we have to serialize the data in order to make it human readable. So in that case, we can use a non-relational database. We need to serialize data like in JSON format or in XML format. And if the data is huge, sometimes it's more efficient to store in this non-relational format if data is in huge amount. So depending on our use cases and considering the advantages and disadvantages of each of these, we can choose which one to use. So now we have looked into, like, with the popularity of Facebook, the database has increased and it has reached to, like, not the database, the users base has increased actually. It has reached to like hundreds of thousands or even millions of users. So single database, we want to have to increase the storage limit or the CPU limit to handle these amount of requests. So let's say we are increasing and up to a certain threshold we can increase it, right? because it would reach the capacity of supercomputers, and every organization would not be able to support or utilize this amount of or expense this amount of money to have a supercomputer parallel storage and memory. So this is like, this factor is like increasing the CPU or the storage of a single, let's say, database server. We are talking about database server. This is called vertical scaling, or we can term it as scale up. It's like adding more CPU or RAM, etc., increasing the storage. So this is favorable when the traffic is low, because but unfortunately this vertical scaling has a hard limit, just like I explained. Like, it is impossible to add unlimited CPU, right, and memory to a single server, and it also does not handle support failover and redundancy. Like, if a particular database server is down, then the entire system goes down, because there is no other server to handle or cater the request, or we can fetch the data from other servers, right? So this is the disadvantage is like there is a hard limit, and it does not support failover. Like, it's kind of act like as a single point of failure, does not support failover or redundancy. So for that, what we can do is we can have horizontal scaling, or rather increase the number of database servers. Instead of increasing the capacity of a single server, we distribute this capacity into multiple database servers, or this is called scale out. So this is favorable for large applications. So this is the fundamental idea of what is vertical scaling and what is horizontal scaling. So now consider a scenario like users are now connected to the web server directly, right? So if suppose a particular web server is down, then users won't be able to access this website. And if this is one scenario, like this web server is down, another scenario is like if hundreds or thousands of users tries to access the single web server at us simultaneously, then in order to process or handle those requests, the web servers might reach its load limit, right? And this usually results in the delay in response, or like fail to connect to the server, these errors which we usually see happens. So what is the workaround for this? So for this we have a load balancer. So load balancer is the best method to handle those problems. So why do we need a load balancer? Firstly, like, what was our problems? So let's write down the problems actually. So first problem was like single web server and it goes down, like it's offline actually. Then in that case we won't be able to access the website, or thousands of requests simultaneously goes to web server and it reaches its limits, and the web server is unable to handle those requests, and we get a fail to connect to server. So for this, what we do is we have a load balancer. So if we look into the diagram, so before diving into the diagram, let's see what is a load balancer. So load balancer helps to evenly distribute incoming traffics among web servers that are defined in the load balance set. So load balancer actually has a set of web servers it can handle or redirect the traffic to, and it has all the information of those web servers, like which web server is handling how much request, and which server is more idle, which server is more busy, and in that way it distributes the load. So the algorithm is implemented within the load balancer, and it distributes the incoming traffic depending on the load on the web servers. So this is the fundamental of web server. So how does it fit into our system architecture? It's like, this is web browser or the mobile phone we have. This is like we interact with DNS. DNS returns the IP address. From IP address, instead of directly going into the web server, we have a load balancer. So what does load balancer do? Upon coming the incoming, it has information of all the web servers. Let's say this is web server 1, web server 2, like this. There are k web servers, and this is web server k, and all these are, let's say, connected to a database. So load balancer, what it does, upon receiving an incoming request, it checks which web server is more idle or which server is busy, and depending on that, it redirects the traffic to that particular web server to handle the request. So here what happens is, like, as we saw initially, we were connecting with a public IP address to the web server directly, but here, for better security, private IPs are used for communication between the servers. So here we use private IP addresses for better security. And a private IP address is an IP address reachable only between the servers in the same network. So however, it is unreachable over the internet. So only, so let's say load balancer and all the web servers know each other's IP address and they can communicate over each other, but an outsider who is not within that same mobile network cannot connect with that web server. Whereas to connect with this web server, we connect with the load balancer, and this is a public IP address. So if now let's see how we are able to solve our problem which we just discussed here, like instead of single web server we have multiple web servers. This is one thing. And how to handle thousands of requests. So like, let's say if server 1 goes offline, the traffic will be routed to server 2 or other servers. So this prevents the website from going offline. This solves the problem 1. And the second is, like, if the website traffic grows rapidly and 2 servers are not enough, so if we introduce another server, then web load balancer is smart enough to know that another server is available. It will gather those information of that server and redirect the traffic to that particular server. So now we have discussed our web tier, like how we scale the web tier to handle a large number of incoming requests, or when we have, if a particular web server service is down, how do we redirect the traffic to another web service. So now let's talk something about this database data tier, how we handle or how we scale out this database to handle or store large number of requests or large amount of data of this particular users. So now let's look into the data tier. So having one database does not support failover and redundancy, as we just discussed about this web server. So database replication, we use something called as database replication technique to address these problems. Database replication. So what is database replication? So it can be used in any database management, many database management systems, usually with a master slave relation. So what is a master slave relation? Let me write master slave relation. So in master slave relation is like when we have a master database node and we have multiple slave databases node. Master database, it supports the write or the update operations, whereas slave databases, it supports the read operations. So like in a particular scenario, if it's a read heavy system, right? So we have a multiple number of slaves where in correspondence to a single master. So suppose in most of the scenarios there the ratio of read is to write is much higher. So like read is to write, let's say, is 10:1. So for that we have number of slaves is much higher in number than the number of master. So how does this actually look in a, if we introduce a single master multiple slave database nodes? So let's look into a diagram. So here we can see we have a single master node which handles the writes operation, and we have multiple slave database nodes which handles the reads operation. And once the write has been performed, so data is being replicated in this database nodes, slave database nodes, to for the web servers to get the actual data. So this, how does this, what are the advantages of database replication? Is like high availability, reliability, we have better performance, we have our data being spread into multiple database centers, so that if one database center is down for some reason, then we can access the data from other database centers, and these are some of the advantages which we have. So what happens if, like, let's say one of the slave database goes offline? So in that case, as simple read operations will be redirected to the master database temporarily, and if in case the data is not being replicated, and if it is replicated, then read operations might goes to another slave database which has this replicated data, and in the meantime the slave database will be looked after and it will come up once it's online. So read operations will be, or in other scenario, if the data is not been replicated, read operations will be redirected to the master database, and as soon as the issue has been resolved, a new slave database will replace the old one. So here what two things can happen. Read operations goes to master temporarily, or read operation can be handled by other slave database if data is being replicated in those databases and they are available until this new healthy database replaces this old database. And this is one scenario. What if, now let's look into what if this master database goes offline. So master database basically handles the read or the update operation. So what if it goes offline? So in that case, a slave database will be promoted to the new master, and all these database operations will be temporarily executed on this new master database. And suppose this slave database, slave database is being promoted here. So to replace this slave database, a new slave database will be replaced here. So there might be some inconsistencies, like suppose if data was being written into this master and it has not been replicated yet in the slave database, but the master goes offline. So when the slave database will be replaced by this, when the master database will be replaced by this new slave database, this one, so in that case it won't have the latest data. So in that case we can have something called as multi-master replication or circular replications. So these things we can discuss in some other video, but these are some of the disadvantages or something which you need to take care of. So in this way, load balancer and the database replication helps us in supporting millions of users. So if we now look into single system architecture diagram of what we have discussed so far and how the actual flow happens of a particular request which is being made by a particular user. So let's look into this diagram. So let's say this is my site, this can be facebook.com, which we have discussed. So request goes to the DNS. DNS in turn resolves the IP addresses. This public IP addresses goes to the load balancer. Load balancer in turn with its private IP addresses connects with the web server, redirects the traffic to a particular web server depending on the load. Let's say traffic goes here. The server in turn, let's say this is a write operation, so it will write to the master database if it needs to read from that, and the master database will replicate the data to the slave databases. If it needs to read from this slave, it will read from the slave database, and upon performing operation on that requested data, it will return back the request to the particular user. So this is the overall thing how a request is being handled. So the user gets the IP addresses of the load balancer from DNS. The user connects to the load balancer with this IP address. The HTTP request is routed to server 1 or server 2 depending on the load. A web server reads user data from the slave database. A web server routes any data modifying operations to the master database, and this includes write, update and delete operations. So now we have a solid understanding of the web tiers and the data tiers. So in the next section, in order to fasten the process of this load or the response time, we will be looking into two more important things. One is the cache, another is the CDNs. So thank you for watching this video and see you in the next video.